All right, so this is the screencast for week 12, November 13th. So let's start with announcements, and we'll try to break today around 6:15. So let me set the alarm for that, and so we'll just go without a break and end punctually at 6:15, and then snooze for 5 minutes, and then we'll be done. So then you'll be able to attend this presentation. So that's going to be on the 13th floor of Lewis Towers, just so you know ahead. Should be interesting. Then brief announcement for next week. Let me see one thing here. Yeah. There will be a presentation in the C++ meetup by Mr. Conrad Weisert, who some of you might know. He's also a part-time instructor in our department, so he teaches courses such as project management. He's an experienced professional, and he's also passionate about object-oriented modeling, and he's going to discuss this issue of the person class, stuff like role-based modeling or other alternatives. So if you are available, I recommend that, but that's off campus. All right. Now, test 2. So if you submitted the makeup project, the little makeup project for that portion of test 2, so that's being graded, and if you haven't included a scanned copy of your test, please add that. Maybe just add that to your submission repository, or you can just give me your test 2 today. I mean, that's another choice. The easiest is, I think, if you scan it or take a picture of it using your phone or whatever best way you have for that, and then just make it part of your private test 2 makeup repository. Any questions about that? Okay. And now we have a project 5. So that's basically going to take up the rest of the semester in terms of project work. And these dates, there's really no wiggle room unless you are looking for an incomplete. It's just that my own grading deadline would be Saturday the 14th. So I absolutely have to have your work, all of your work, so that I can then submit the final grade. So even this is kind of pushing it a little bit for me. I have to kind of evaluate your work on that, or finish evaluating it on that Saturday. But I just want us to have enough time. So there's a required in-class demo. So actually doing the demo is required for full credit on this project, but the demo doesn't have to be, let's say, polished or demonstrate, let's say, 100% of the functionality. So, that even if, let's say, your project is not completely finished by the demo date, you're still expected to give a demo, and you should think about that as an opportunity to get feedback on your game. But so, just very briefly, the overview is basically the idea is to have fun in applying the various things we're studying here in the form of a game. And this is a fairly simple type of game where the idea is just to use the touch interface to have this time a model view controller architecture as opposed to the one we're used to, which is model view adapter. So here we're going to have a custom view that shows these monsters moving around, and then the monsters alternate between an invulnerable and a vulnerable state, and then when they're in a vulnerable state, you just press on them and they go away, that type of thing. So this gives you the details. I don't want to distract you too much as you're wrapping up Project 4, right? So obviously you're focusing on that now. But I did want to give you a heads up just to let you know that this is here now, and you can start working on this as soon as you're close to being done with Project 4. Okay, but we will have a little Project 4 discussion later today. So anyway, I'm hoping that this is enough detail to get everyone started. And of course, next time we'll have a kind of a kickoff discussion here. So just wanted to share this ahead of time. Any questions so far? There will be a Project 6 also. So you might say, "Ooh, how are we going to fit a Project 6 in here?" But yeah, no. Project 6 will be an optional extra credit add-on to this one. So no, it's all reasonable. I mean, I'm not that crazy. So all right. So okay, it'll be reasonable. It'll fit within the parameters of this project. Okay, very good. So that's that. So let's see where we stand. The other thing is I updated this weekly schedule a little bit and fixed some of the listening assignments. So, and then I also moved around some of the reading assignments. In any case, for the purpose of the test, which is scheduled for next week, you'll be focusing on the roadmap that I'm going to provide you anyway. So don't worry too much about the general reading, right? But so I think I might have just added this yesterday here, but this is the one to listen to because we're going to start looking at concurrency issues in a little more detail starting today. We sort of set the stage for that last time when we discussed in detail about the events coming from the timer thread, that they would be in a different thread from, in some sense, competing events coming from the user interface and being processed on the user interface thread. Okay, so we're going to look at concurrency issues in somewhat more general terms today as well. So that's why this episode, again, these episodes are somewhat, as usual, high level, and they can be advanced in some of the terms they use and issues they address. But the idea is, again, to just sensitize ourselves for subsequent discussion of some more concrete, specific aspects of these topics. Okay. So let's look at the agenda for today. So let's see. So basically what we're going to do here is wrap up the discussion that is really based on the first 6 chapters of the book, which is, the Uncle Bob book, which is where the lightweight or development process is being discussed. And there's another good resource. Anyway, so there's some links here to some presentations. Of course, so I'm not going to go into too much detail here on test-driven development and JUnit because we've been doing this for the whole semester so far. And I really just want to give more of an overview and then tie that to this overview of the key elements of a successful development process, and then go into a little bit of refactoring, and then talk about design issues and things that can go wrong with design, so-called design smells, and then transition to or set the stage for a more detailed discussion of the design principles, some of which we've started to touch on. Okay. And then we need about, I guess, maybe about half an hour for the concurrency stuff, and some time for Project 4 discussion. Okay. So many of you have heard of different kinds of software development processes, such as rational unified process, personal software process, or team software process, etc. Who has taken a course here in software engineering or elsewhere? So you have at your other institution. So some of you are probably going to take the undergraduate course 330 or the graduate course 374 as part of your curriculum, right? So here, we're focusing more on structure. So architecture is part of structure, and we're kind of de-emphasizing process. But even though we're de-emphasizing it, we're still following a lightweight and useful process. Okay, and these are the ingredients that we're about to discuss. Whereas the 330 and 474 courses focus on a more explicit, kind of more deliberate process. Okay, so the kind of process that you might find as a standard across a large organization, that type of thing. Okay, whereas what we're doing here is maybe more like what you would see in a startup or so. Okay, and this reminds me. So we have a guest speaker lined up for December 4th. And this will be Dave Turner from a company called Waitbot. This is an app that's already on the Android market. So if you look for Waitbot, you will get a preview of what it's going to be about. But so I ran into him at this Android birthday event, and he's interested in talking to us about some of the experiences they had in producing this app, so from both a software and a kind of strategy and marketing point of view. Okay, so I'll keep you updated on that. Anyway, so then the question is, what makes for a successful development process without the process becoming heavyweight or very focused on deliverables besides the code itself, etc. Okay, and there's a nice book that I think we have here in the list of supplementary resources. So let me pull up the Piazza site, and we'll go to the resources section. Let's see where that is. What's going on? Here we go. Okay. Resources. It's actually on this other page. Sorry. It's rather here. geez, where it's not even listed. Okay, let me just pull it up. Somehow that entry that must have been there at some point got lost. I'm talking about Fowler UML distilled. Okay. So that's a very concise summary of the most important parts of UML. Somehow the network, I think the Wi-Fi network is really slow right now. So here it is. This is what the book looks like. So you can get it used for a good price. And he basically has a summary of what are the key ingredients of a successful process, and they are basically embracing a test-driven approach and refactoring in an attempt to avoid the gradual deterioration of the software, and maybe even turning this into an opportunity gradually to improve the quality of the software, and then some notion of continuous integration and delivery. So who is familiar with the concept of continuous integration? Do you want to give a brief description?
Oh, just kind of the idea that you can continuously push code to production environments without having to do massive downtimes or scheduled maintenance. And kind of that like also being in, so like your process from QA to production and tying in those branches is kind of seamless.
Yeah, that's a good characterization with a focus though on continuous delivery, right? But so they all tie together. I mean, so continuous integration, delivery, and this emerging paradigm of DevOps, right? Tying together kind of the development side of things and the operations side of things, which historically used to be pretty separate, and it's now more and more considered to be a good practice for the developers and the operations people to cooperate, more directly. Okay, so Michael, did you have any additions to?
I mean, we're using distributed systems. So Joe Taylor, he's using continuous integration. We put all our code, everyone's code was put up there, and it recompiles it and tests it all the time. And anything you put up, it will test it again.
Okay, nice. So that's a focus on the continuous integration part, right? So that's good. So nice complementary answers. So the thing I'd like to emphasize is that in continuous integration, basically when you do a commit of your changes to the repository, so this will trigger automatically a test, like a build and a test, and maybe certain other steps on a shared environment that's known to be set up in some good way. So as opposed to, right, just on the developer's own laptop or development machine, right? So the key point here is that by having this kind of a setup, just this initial part, that a developer cannot say, oh well, but when I tried it, it worked on my machine, but then when, let's say, someone else pulled the changes, it didn't work anymore on their machine. So that's not uncommon, and continuous integration basically says, well, we have this common point of reference, which is a continuous integration environment or a server that we set up, and whenever there is a push or a commit to the repository, those those changes get picked up by the continuous integration environment, and then the build and the tests get triggered, and you find out immediately if something went wrong. So basically, you could get notified immediately, or the lead developer could get notified immediately if something goes wrong. So the turnaround time is going to be much shorter for dealing with a new issue than if you have manual builds or even regular, even nightly builds, which are a common practice. You probably won't be able to address the issue until the following day. But with continuous integration setup, you have a chance to address issues almost immediately, within minutes. So this is a very nice setup in that sense. And so the way it works, they're basically continuous integration server packages that allow you to equip a designated server, or typically a virtual machine nowadays, in either locally hosted or hosted in the cloud. So a virtual continuous integration server in such a way that these changes get picked up there, and then the build and the test get triggered. And then continuous delivery is when this is taken further, even so that assuming everything succeeds, then the new version with possibly new features get pushed out within very short turnaround time to your users ultimately. So I guess when you're doing a mobile app, this could be maybe automatically pushing the app out to the market, right? To the App Store or Android market, that type of thing. And then your mobile users will notice this, because it'll tell them that an update is available. So that's for a mobile app situation. But then from the point of view of, let's say, a web app or a web service, it could just be pushed out by deploying the new version to a server. And then one could, depending on the type of software, one could even have it so that certain components can be reloaded while the service is running. So that can be set up in certain environments. Okay. So, meaning, to summarize this part, there is the possibility of having proper tool support for this type of process, or this ingredient of the process. But even, you could take a more general and less formal view of continuous integration, and you could say, well, really the key aspect of this is that when you start and you continue working on your project, that you want to have at all times, even from the very beginning, even a minimal but running system. So even with very minimal functionality, but as long as you have a running system, you can run functional tests against the system, or you can use the system even with very stripped down functionality. For example, when you're doing web application or service development, even having some kind of cloud-based host like Heroku, where when you commit your changes, it'll basically rebuild the application or the service. So that is, in some sense, a lightweight continuous delivery mechanism, right? Because it'll basically deploy the rebuilt application immediately. The problem is, well, if so the sense in which it's not quite there in terms of being a full-fledged continuous delivery solution is that if something goes wrong, well then you don't have a running app. You know, whereas with a proper continuous delivery mechanism, if the build fails, it won't replace or shouldn't replace the app that was deployed previously, right? I mean, otherwise you don't have an app. But you know, you could kind of you could think of Heroku and similar systems as kind of a lightweight mechanism that gets pretty close to this idea of continuous delivery. Okay, so what is the other ingredient? I mean, we're familiar with test-driven development. Just to recap, the idea is, you know, the overarching idea is that one shouldn't think of testing as just an afterthought. So the idea is, when you say, okay, I'm going to have to develop this class or component, you ask yourself, well, what are the responsibilities of the component? What functionality does it expose, right? And how do you express that, the answer to these questions? Well, in the form of an interface, right? So you say, okay, this interface, you know, or similar language mechanism depending on your language. So this interface expresses what I'm going to expect from this component in terms of the very basic description of the capabilities in terms of method names and argument and return types and things like that. So it's a kind of basic contract, okay? And once you have that, you can say, okay, well, now I can write code that tests the functionality, and concurrently or, you know, alternatingly, I can write code that implements this functionality. So that's kind of the idea. You know, you kind of develop the functionality and the corresponding tests together. And the point where they meet is your contract, your interface. Now, of course, as we saw in test 1, right, where we had to do the reverse engineering, you know, that was basically a type of test-driven development where it said, okay, here are the tests. So in an even more extreme sense, saying that, well, here's how we want the thing to work once it's there, and the tests express that vision, and then we even reverse engineered the interface from the tests. So in practice, you would write the interface and the tests together, because the tests wouldn't compile without there being the interface or other kind of construct that you'd be able to compile against and try to run the tests even if they failed initially. Okay, so the idea is basically to have the interface there as the common point of reference, and then to work and make progress on both the tests and the functionality. And then the idea is, well, the way this ties into the other parts of the process is that passing the tests would be a requirement for delivery, and having automated tests is a requirement for having a notion of automatic or continuous integration or delivery. Now, the refactoring, so we've looked a little bit at refactoring, and I believe you listened to the episode. So the definition of refactoring is you make a change that doesn't change the functionality, but changes the non-functional implementation or structure of the software. Okay, so typically, when do you want to do a why change something if it doesn't fix a bug or doesn't change the behavior, it doesn't enhance the behavior or correct the behavior of the software? So refactoring is very closely tied to the idea of the quality of the software in terms of non-functional requirements. So it ties back to some of the discussions we had at the beginning. Okay, and one can express the non-functional requirements in specific terms, these non-functional qualities such as scalability, testability, etc. So I think we had these up here, right? So these kinds of non-functional requirements. And what you typically do is, in terms of the big picture, apply refactoring in an attempt to improve the non-functional quality of the software. So that is kind of the bigger picture. And if you actually drill into the code, you can detect violations of non-functional requirements in the form of these little code smells. Okay, so a code smell is kind of a symptom of, it's kind of a small, detailed symptom of a possible or likely violation of a non-functional requirement in terms of software quality. And okay, that's a presentation, but I think there's a okay, here. We don't want the presentation now. We actually want to look at what the possible code smells are. And there is basically a nice categorization or taxonomy of these code smells. And these are things you see when you look at the actual source code. So one would be long method. So if you have a method that goes over several screens, you might want to ask yourself, does it have to be like this, or is there maybe an opportunity to break things down into smaller pieces that are easier to understand and easier to maintain? Those kinds of things. So it ties to maintainability, and if something is that complex and it's expressed as a single method, there's also no way to test the individual steps within such a method, because you cannot get in there, right? If it's just a single monolithic method, there's no way to test the step or whatever code is there somewhere in the middle of that method. It's just not exposed as something you can tap into. All right. So some of these are more familiar than others, obviously, but these are, this is a good taxonomy. It's also entertaining to read, and there are these descriptions that make sense. But probably one of the most familiar ones, well, one that ties very nicely to a discussion we had recently is this one here. So when you're writing object-oriented software and you see switch statements in the software, then you would immediately wonder, why isn't this being done using which mechanism? Well, switch or if-then are interchangeable, basically. But so, how do you do branching normally in an object-oriented style? Well, composite takes advantage of this mechanism. That's right. So we're on the right track. But composite is a pattern that uses this underlying mechanism. But there are other patterns that use this as well, right? But so we don't normally expect to see an explicit branch in a proper object-oriented program. So how does the branching happen? So again, visitor pattern takes very big advantage of the underlying mechanism. That's right. So in visitor pattern, you're kind of using this underlying mechanism that's built into the language to make something look very close to an explicit branch. But what's the mechanism itself? Inheritance, not necessarily. I mean, it can happen without actual class inheritance.
Like a branch in assembly is just like a method. So.
Right.
What you're getting at?
Well, yeah. I mean, kind of. I mean, I'm getting at this idea that, or anyone else. I mean, someone should be able to respond. I mean, so the idea is that you have an object, and you invoke a method on the object, and what happens then? How do we find the method? So so you say something like x.f. How do we find f in the source? How do we know which f will be invoked? Pardon? I mean, it has to do with what aspect of this receiver object X? The dynamic, right, we're getting closer. Right, so in other words, X has a dynamic type that could be different depending on a runtime situation. And the method is chosen by searching for it, starting with a dynamic type of the object. That's right. So this is called dynamic method dispatch, right, or dynamic binding. That's right. So in other words, if you have x.f, something rather, then again, remember those steps. First, in a statically typed language, the compiler checks, well, let's look at the static type of x and see whether there is an f in there. And if not, it says, well, this cannot work. So that's it. But if the compiler says, oh, there is an f in the static type of x, okay, that's good. So we'll let this happen at runtime. And then it sets it up so that at runtime, f is chosen from the dynamic type of x, meaning that either that dynamic type inherited, it either defines its own f or it inherited f. So the way you can describe this commonly in the presence of inheritance is, well, let's look at the dynamic class of x, see if there is an f in the source of that class. If there isn't, then we look at the superclass and so on. Right? So inheritance is present in this, right? But it's not required because we might have a situation where we have an interface I and then implementing classes C and D. So strictly speaking, there's no code inheritance, but the dynamic method binding happens anyway. The choice between C and D. So where is the branching? The branching is implicit inside this dynamic method lookup mechanism. Okay? And in object orientation, normally when you have these different choices, you often have, or typically have, classes representing these choices, and you just have a method invocation that represents an implicit choice. So remember how let's see, in all of these recursive methods that in some sense are tree traversals, like calculating the size of a tree, the number of fruit in one of those fruit trees. So there was a method for, or a version of size for each kind of tree node. And then instead of the way you would do it in a non-object-oriented way, you would say, okay, here's the size method, so if the node we're looking at is fruit, then we return 1. If the node we're looking at is a branch, we add up the sizes of the children, and there's your recursive invocation, right? So it's all the same, but so in an object-oriented approach without visitor, that explicit branching is replaced just by the fact that the receiver object, the tree instance we have, might be an instance of one class or another class, and the method gets chosen based on which one it actually is. So that's why you don't expect to see explicit switches, or then in the visitor pattern you're making it semi-explicit, but there isn't a switch statement or an if-else statement. There's just the accept, and in the accept there's the step with the accept, and then the step with the visit me, and that indicates which of the branches should be chosen, but there isn't an explicit switch or conditional. So without or with the visitor pattern. So that's why when you look at object-oriented software and you see a lot of switches, you might say, well, did they really use proper object orientation in terms of a class hierarchy corresponding to alternatives of alternative implementations of a particular concept, such as what you would have in composite with decorators, that kind of situation. Okay, so that's a familiar type of situation. The other one that's really simple and common is this idea of duplicate code. So violating the DRY, don't repeat yourself principle. So that's here. And then there are a bunch of others that are more advanced or complicated. And some of these smells are smells where the situation is very clear, where the right choice is to get rid of them. Like duplicate code, you almost always want to get rid of that. Whereas there are others where it might be more of a trade-off. Okay, so this message chain situation. So this really depends, because you could argue, well, if you have something like a fluent interface or fluent API where you can write successive method invocations to form something that looks almost like a sentence in a natural language, where you successively apply another step to the previous result, there you will have these chains. So, but there are other situations where they might be desirable. So I would say some of these smells are more of a trade-off. Others are very clear-cut, like duplication or global variables. Okay. All right. Any questions so far? So this gives you an idea of these kinds of smells that are called smells because when you look at the code, something feels like it's not right. It feels or looks icky. It needs improvement. And refactoring is essentially a mechanism for eliminating smells without changing the behavior. So that's always the one thing to keep in mind. Okay, so there are these refactoring catalogs. For example, this one is by Fowler. And yeah, refactoring is another one of these examples where Fowler did a really good job at spreading the word, evangelizing these insights among the professional community. But he didn't come up with this. Does anyone know who came up with some of these ideas? Not far from here. I mean, not in town, but not out of state. So, where could that be? What's a place where there are a lot of smart people, when it's not here in the Chicago area? That's right, exactly. So the person is Ralph Johnson. So here, Ralph Johnson, computer scientist. So he's a prominent exponent of the Smalltalk, the networks, very slow, of the Smalltalk community originally, and he was one of the co-authors of the Gang of Four book. So a lot of the design patterns work, he contributed considerably to this. And this is just a really short page, but you can look more at the at his own materials. So see here. So I do a lot of research in refactoring, and so that's where that started. All right. But yeah, so there's an interesting division of labor in the sense that it's useful to have people to spread the word of useful stuff going on in different places in academia and making the professional community aware. And then from my point of view as a teacher, I also look at what the professional community does, and I'm trying to bring some of that back into the classroom. So there's an interesting cycle of information flow there. Okay. So what do we see here? Let's look at some typical refactorings. So, for example, this is a really good one. Extract superclass. So all of these are, and this is kind of a summary of the Fowler refactoring book. So what you see here is the before and after. All of the refactorings are described like this. So here's the smell. Where's the smell? Oh, okay, they both have a get name method. There's even the same method name. Okay. Then they have a method that might be the same in idea, but the name's not exactly the same. So this requires usually some actual human insight and actually a developer taking a look at this as part of a code review, maybe. You pair up with others and you do a review. Okay, and you say, this is the total cost or the annual cost for the whole department. So I mean, you don't really need this word total as part of the name. So you say, well, okay, this is the annual cost for the whole department. So there goes the total. This is the annual cost for this employee. And departments and employees both have a name. They're entities that have a cost. Or you could just say more generally they're a party or a group. And you say, okay, well, we'll pull out this common functionality and express it as a superclass or interface. You know, so superclass you really want to think of as maybe a super type more generally. So it could be an interface. And in languages without interfaces like C++, you would have an abstract superclass usually. And here are the implementations. What is being expressed here in this particular example, so this is in italics, and so is that, meaning that this is abstract and this method is abstract. So the class is abstract and the method. But the getName method might be fully implemented because the name might be an attribute at this level. Okay, so there are different possibilities here. The key thing is, you know, the key elements of a refactoring are the before and the after, and then, you know, what situation you're looking at and what the remedy is to eliminate the smell. So a catalog of refactorings would be a collection of these kinds of things. And there has been a trend looking at design patterns and smells and trying to take an opportunity to say, well, we have to, you know, there's a smell here. Let's try to do a refactoring so that as the result, we have a desirable design as reflected by maybe a specific design pattern. So that's where you see, so there's a book, I think it's called Refactoring to Patterns. Okay, so tying these two ideas together. And, you know, there are some particularly mechanical refactorings, so to speak, that are built into your development environment. So certain development environments support this. So if you pull up Android Studio or IntelliJ, you know, you have, there's a grayed out now, but, you know, so you have, let's see, it's working, loading. The famous beach ball. So usually that's bad news, but I know that right now it's doing something, so I think it's going to go away shortly. Let's hope. Maybe I should have left it alone when it was still loading. Oh, man. Okay. Yeah, that's bad news when it says not responding. Okay, so force quit. It's embarrassing, right? The Apple user having to demo the beach ball and the force quit. Okay. I'll let it do its thing. Just so we can look at the refactoring menu properly. There we go. Okay, so, well, it still says process is running, but okay. So that's actually instructive. So you see how it has support, you know, direct support for some of the refactorings in Fowler's catalog. And see, even stuff like extract superclass, the one we just looked at, is here. And that would, of course, you know, require me to select a class, so we can even try what happens, if, I don't know, if we select this, and we could try, so it would even give me this option to extract an interface or a superclass. You see the refinement here? Because this understands Java, it knows that we could extract a super type, which could be either an interface or a superclass. So when I make this choice, I think it's going to ask me some questions. See, so it lets me choose the methods I want to be pulled out and placed into the interface that it's about to create for me. But so it's nice to have tool support for these different refactorings because supposedly it makes things less error prone. Although some of these things are a little delicate, and these any kind of tool that performs manipulation of source code, it might mess up your source code. So you hope that won't happen, but these tools aren't necessarily error-free. So, for example, sometimes it might just lose part of your code, but it's no problem because we use version control, so we can just say, okay, well, let's revert to our previous good version. And this also encourages everybody to make relatively frequent commits. So you don't want to have 2 weeks worth of work without committing the work, because all kinds of bad things might happen. But I'm probably preaching to the choir. We all agree, I believe, that version control is a really valuable thing, especially when you actually push to a remote repository. Okay. Great. So we could see how this refactoring is actually supported by actual tools. So that's good. And the real-world significance is basically, in a phenomenon called code entropy. So what does entropy mean? It basically means when you have a system, over time, the system will not get any less messy, so to speak. So entropy means the amount of disorder in a system. So it's originally a term from thermodynamics. They have these laws that involve entropy, and I was a physics undergraduate, and it's just stuff that I really don't remember well anymore. There's other stuff I might remember a little better, like the electromagnetic stuff a little better. So, for example, I know that if you have a network cable, right, so you want the waves to propagate, so you shouldn't really have very tight turns here, or very sharp turns. You really need minimum radius for the wave to be able to propagate nicely without loss of bandwidth. So this kind of stuff I can relate to. The thermodynamics, somehow I didn't warm up to it much, but now I'm kind of appreciating this more in this context where we're looking at software as the system that evolves. Okay. So this idea of the software entropy means, well, when you have a team, realistically a piece of software is something that has a fairly long life. So it might have gotten created at some point in the past, then developers join, they participate. They might not be fully aware of the original architect's vision, so they might do things a little bit in their own way. They might not be aware that there are certain maybe components that provide that functionality already in other parts of the system, or that they should use a certain library for support with certain functionality. And then what happens? The entropy increases, or at least it typically doesn't decrease, and smells arise. Okay, so you could say a smell is basically a sign of excessive entropy in the system. And the idea of refactoring is to bring this back under control, so to kind of bring some order back into the system. All right. And it ties to this bigger picture also of economy of scope versus economy of scale. And looking at this in detail goes beyond the scope of this course, but there's a link you can look at. Anyway, so that's the role of refactoring and how refactoring can help us despite these inevitable facts that projects have kind of a life of their own, and people come and go, and things can get messier. So refactoring helps us to deal with that in a way that involves very, very small and very specific steps, and steps that in some cases, as we just saw, can have tool support, like this kind of extract interface or extract method, all of those things. So basically, many of the refactorings in the catalog can be automated or at least supported properly. All right, any questions about refactoring? So just keep this in mind as part of your vocabulary and your toolkit and mindset. So in some cases, depending on the phase of development that the project is in, even just recognizing a smell and marking it with a to-do comment or a fix-me comment or so is a valuable contribution, right? So you could say, oh, this doesn't look right, so you might, but you don't have time to fix it right now, so you just say, you put a to-do or a fix-me, and then in your tasks or to-do view, it'll show up. So you'll make it a habit to look at your to-do view occasionally, and then you might say, oh, now I can come back and fix some of these smells. At least that way you won't lose track of them. And if you're lucky, some of your code goes away because there's a library that already does that kind of stuff. And then the code goes away with the to-do. That's a lucky situation. I mean, in general, also in terms of entropy, so one aspect of this is how much code there is, and it's generally desirable to keep your system as small and simple as possible for this very reason. So this means anything that is already provided in an adequate way by a library that you can simply depend on as an external dependency, you're better off to refactor in such a way that you're relying on the library unless there are issues with it, unless it's buggy or has performance issues or other issues. All right? Okay. Great. So that was kind of my overview of refactoring. Now to look at slightly higher level of agile design and architecture. So the smells that refactoring addresses are kind of, in most cases, relatively detailed smells, kind of smells in the smalls. Whereas some of these design smells are more about larger things in your code. Okay. So for example, how difficult is it to change the system to address requirements that have evolved? And so this one is, of course, this is part of the refactoring catalog. For example, when you have duplicate code across classes, and you could really pull out a superclass. So that's a more specific one. But some of these others are more architectural, meaning more overarching. Okay. And what we'll do is we'll look at these in conjunction with the next thing that you might ask. So how do I deal with or prevent these design smells? So how do I design so as to achieve a good outcome that doesn't have any of these smells? And here the idea is to use, of course, design principles and also design patterns. So we've looked at some of both, right? But really the fundamental guiding mechanisms are the design principles, and the patterns are somewhat more specific, right? So patterns are typically consistent with design principles, but patterns are, in most cases, solutions for solutions to specific problems, whereas the principles are more general and also more overarching. Let's see. So let's start with this nice. Whoops, that's the wrong one. With this presentation here. Okay. And really, the main thing before we go into that, I want to reiterate this idea that developing software, a big piece of which is design and making decisions. Do I do it this way or that way? So that's not a single event. Saying, for example, today at 5:30 in the afternoon, I designed this piece of software. And that's not how it happens. So it really is a process or even a journey, where you come back and you revisit some design decisions. You might look at them from a different angle. You might decide, well, I was looking at this trade-off in a certain way back then, but now I'm thinking of it differently. So I'm actually going to resolve the trade-off differently. Okay. So that said, let's take a look at this nice presentation here on SlideShare. So this is a good overview of design smells and design principles. So that's the presentation link. And so here, this issue of software entropy is discussed, right? So let's go fairly quickly. So familiar face here, Uncle Bob. So this book and to downloaded this somehow or preloaded, I guess. I mean, this is the whole business model of Google, right? The assumption that we're always connected, but it's not necessarily even here the case, in this environment. So yeah, this is another very useful, very very pragmatic book. So I recommend taking a look at that. And so increasingly in the Agile community, the view is that the source code itself is the design, as opposed to these more explicit processes where the idea is, well, there's a design document, and then the source code has to follow that design document. Okay, so in the Agile community, this is kind of the understanding. And the idea is that a UML diagram can be used to communicate, to represent or communicate part of a design, but it isn't the design itself. Okay, so that leads to this idea: you code, you test, you refactor, I mean, you correct errors and you refactor. So the developer is the designer from this point of view. This is also tied to the idea of the lean architect. So at some point you will have an opportunity to listen to the first software engineering radio episode on architecture, meaning software architecture, and it'll give you an idea of what architecture is about. But as I was just starting to discuss earlier, so architecture is when there are these more overarching issues that have more impact, as opposed to, let's say, a localized design trade-off. Okay. But still, the connection is, if an architect works away from the code, then they're out of touch also with this idea that, well, the source code, in a way, is also where the architectural decisions are ultimately expressed, right? So the source code is the design and the architecture, and therefore it's important not only for the designer and the developer to basically be the same person. It's important for the architect also to be involved in development, and there's an organizational design pattern called the lean architect, or architect also implements, right? This is a body of work where this idea of software design patterns was generalized to organizations. So you have organizational patterns that talk about organizational structure. Is there a very deep hierarchy, or is it a flat organization? Those kinds of things. Okay. So software tends to degrade and rot. So I don't know about the bad meat part, but I mean, there are these smells that evokes this idea of the smells, and in addition, so the cost of change, it gets increasingly expensive to change something, and let's say it depends on certain parameters. Who has had a chance to listen to the embedded systems episode? Wasn't that for last week or something? Right? Anyway, listen to those episodes. They are extremely instructive. The embedded systems episode explains very nicely some of these things when an actual production system is involved. Imagine the effort actually to change a hardware circuit. So this is mostly here, we're looking mostly at software. But let's say you're mass producing, let's say, a watch, an electronic watch. And you've started producing the actual circuits, and you noticed, oh, this is not designed right. I mean, this is a huge cost. Whereas pushing out a new firmware version to an embedded device, like a Roku or those kinds of devices. I mean, imagine if Roku had gotten the hardware wrong before shipping out the devices. I mean, that's a huge disaster. Okay, and by comparison, just pushing out a new firmware version is fairly painless, but even that has to be done right, and it's also costly. Anyway, so it's good to catch errors early, but then again, requirements evolve, and you don't always have a chance to fix something before you haven't implemented it because the requirement wasn't there earlier. Okay. So, there are these estimation issues. I don't want to get into too much detail here, but the idea is that productivity can go down over time, in part because the complexity of the code goes up. So these are the smells that I was referring to earlier, and there's some good explanations for these. So rigidity means hard to change, fragility easy to break, immobility hard to reuse, viscosity that's kind of a little harder to understand, but it means when there are different ways to do something seemingly similar or the same, and it's not obvious which way is the right way. Unnecessary complexity, unnecessary repetition. So this is the DRY, copy and paste. That's what they're referring to here. And then opacity, when something's not clearly expressed, so it's impossible to understand. So these slides give a little more detail on these smells. Okay. So I'm going to just move through these a little more quickly so you can take a look. The viscosity one, let's look at this actually. They characterize it like this. So when it seems like making a certain choice is easy, but it is actually the wrong choice. So this could have to do, for example, with a learning curve of a tool or a framework, where you might say, instead of overcoming this learning curve, I'll just do it this easy way, but then you pay a cost later. But when such situations arise, that's when you basically fell victim to viscosity. So needless complexity can appear in two variants. One is when simply things are designed and implemented in ways that are more complex than necessary. The other way is when there's stuff there that isn't needed or needed yet. So that phenomenon is also often called BUFD. Does anyone know what this means? BUFD. Anyone? So in the community, this stands for Big Upfront Design. So this is discouraged. It means really you're anticipating all kinds of things that you cannot know yet, and you're designing, and your design results in excessive complexity that might not even have a payoff later. So it's this idea here, if something's not currently or imminently useful, don't focus on that. Maybe defer defer that effort until you know what you need, what you're going to need. Yes.
Is that similar to the head-on versus design?
Oh, the head. Okay. I know about these books. You mean? Head first design patterns and those kinds of things. They're probably based on the idea that one should not do a big upfront design. I mean, I'm not myself. I'm not that familiar with the details of those books, but yeah, probably they will do that. And then here they actually call it dry. Don't repeat yourself. And it's a kind of a liability to have multiple instances of the same code because they might get out of sync. And the code base is also more bloated. Okay. So the key here is you want code to express its intent well, and if it doesn't do that, then it's opaque. And what I was summarizing earlier, so requirements change, people change, and there's usually schedule pressure, and the traditional waterfall process is more challenged usually, even if it's iterative or incremental, because there's more lack of feedback. So the idea of agile processes is that there's frequent feedback and you can respond to problems much sooner as opposed to some later point in the future. And in the Pragmatic Programmer book, they talk about the broken window phenomenon, so it's really from sociology. And the idea is you really shouldn't allow smells to linger around too long. So it's better to keep things nice and tidy so that there's a culture of keeping things nice, as opposed to a culture where you say, well, that part's broken, so it doesn't matter if my part over here is broken. So the idea is to have zero tolerance for broken windows. So what can we do? So this is really where we look at ways to, or we look at mechanisms to guide us. So the design principles, design patterns, and the practices. So the practices are really basically the ones that Fowler, these kind of minimum ingredients, so automated testing, refactoring, and some notion, even a lightweight notion of continuous integration where you run these tools frequently and get continuous feedback whether something's wrong or get affirmation that things are working correctly. So product life cycle, cost, and if you have this kind of combination of these ingredients, you're hoping to get this lower cost. So I'm personally, I don't look that much at process stuff, and I'm not sure about the quality of studies that look at these things. But in the software engineering community, they do try to measure these kinds of things. Now here's an interesting term that everybody should be familiar with called technical debt. So you could say technical debt is basically the amount of deferred liabilities or smells that you decided, I'm not going to fix it right now, I will let it accumulate. And then when I have more time, I will fix it. So in a way, you should not let technical debt accumulate over too much of a time frame. So here, see how what you see here is these basically these drops. So here, you kind of just in this phase work to try to keep on schedule and do things maybe in a dirty way just to get it to work. And then you say, okay, let's clean up all the technical debt we have accumulated by doing kind of a massive house cleaning event where we look at all, everything all the smells, everything that could be refactored. And so the difference really between the purple and the green is here you have such short cycles that it doesn't really show up in the curve. So maybe if this is a year, then you have maybe 25, if you go by biweekly, which is what many of the Agile methods recommend. Let's say you have a biweekly cycle, even that wouldn't be strictly continuous. Continuous means really you do things not in discrete cycles, but you do it like a continuous function in math. So stuff is always happening. So it's a smooth curve. And then again here, some more results from studies. Again, I'm not familiar with these, and these are floating around. I'm not myself an expert in this type of study, and I'm not sure about their quality. But there is this kind of evidence that suggests that traditional processes are less effective and more costly than some of the leaner processes. So now I'm not sure whether you can really have a flat cost curve. That's very ambitious. But yeah, we'd have to look a little more at these studies. But let's actually jump now to the principles. So some of these are already familiar, right? So we looked at, in the context of some of our examples, so we looked at interface segregation principle in the context of the stopwatch example. By the way, I still haven't been able to get the roboelectrics to work. I tried different things. There's just something either I'm not doing right, or when you try to when your adapter that gets shadowed in roboelectrics terminology, when the adapter is supposed to receive events, maybe something's not functioning right. So I have to dig a little deeper, and I'll keep you posted. And for the purpose of this project 4, if you have working instrumentation tests, that's fine. It doesn't have to be the out-of-emulator roboelectric test. If you have proper in-emulator instrumentation tests, just like the ones that are supported by Android Studio, in conjunction with component-level unit tests, that's okay. You don't have to have roboelectrics. I like roboelectrics, and I was hoping I'd get it to work, but it just hasn't happened yet. Anyway, so in stopwatch we have this interface segregation principle. So, for example, there are some components that implement multiple interfaces, and depending on which component is interacting with the component with the multiple interface, from the point of view of that client component, it sees it as having one of these interfaces. So that's where we saw the interface segregation principle. And then dependency inversion we saw all over the place, in the sense that all the dependencies were on interfaces as opposed to specific implementations. And then this one we also discussed. That's why we had a rich structure in our stopwatch model, right? As opposed to having a single model with responsibilities of keeping track of time, keeping track of the state within the state-based part of the behavior, and generating these internal ticks, right? Instead of having a single component responsible for all of that, we said, no, we got to break this up so that the complexity is manageable. So it looks like we have complexity in terms of having more classes, but each of these is relatively simple. right? And then the state machine we broke up into classes, one for each state to keep it even simpler in terms of the size of each class. What increases is, of course, the complexity in terms of the number of classes and their connections, but that at least one can look at, whereas if everything were, or that is more manifest, that one can actually comprehend that, whereas if everything's shoved into a single class with fairly little internal structure, it's really not explicit or manifest, and that makes it much harder to comprehend and deal with it. Okay, so open, closed, and Liskov we discussed in the context of subtyping. Open, closed, I said, was kind of harder to comprehend, and we'd have to look at it in more detail. Okay. Yeah, so single response, this is the kind of thing where it's really a guiding principle, and this is the kind of thing where it's not clear-cut. So where it takes, so what does it take to get it right? So if you hear this, what does this mean to you? What do you think it takes to get things right at a higher rate of success? So it's the kind of thing where experience usually helps. If you've looked at different situations where you evaluated a class or with respect to this principle, and then if you've seen different choices, if you've gone through this kind of process frequently, then you have the experience, and that makes it more likely to get it right. Okay, so a lot of the design effort benefits from experience, from looking at a lot of code, from practicing a lot. So that's why I always encourage everybody to practice as much as you can. And that's why it's also important to have this strong connection between design and development, and even architecture and development. All right, so open, closed, let's see if there's a little example there. That's good. So how does open, close work? Well, so the idea is building blocks or entities in your software should be open for extension, but closed for modification. So the idea is extension, well, you want to be able to plug in some kind of additional functionality, additional behavior or so. But closed for modification, meaning that there should be a guarantee of some kind of compatibility with the expected behavior or with the current contract. Okay. And when you look at the strategy pattern, okay, look ahead here. So what's a good example of a strategy pattern? As I mentioned, let's say if you have a sort method, and you look at, you recognize that in a sort method, whether you sort in ascending order versus descending order, the only thing that differs there is the comparison method. So in which order you're doing the comparison. So yeah, so that's a classic example of where you could refactor to the strategy pattern. So you say, well, you really need only one sorting algorithm, and you parameterize it by what the comparison method is. So that gets plugged in as your strategy. Does that make sense? So in the Java collections library, you can see this. So there's a general sort method, and there's one version of the sort method that uses a comparator as the parameter, and that's the strategy. Okay. So in other words, so there's a piece of the algorithm that can be plugged in and determines or parameterizes the behavior of the algorithm. So here it could be a strategy, specific strategy. This could be the comparator. This could be the strategy. The concrete strategy A could be ascending order. Concrete strategy B could be descending order, and they have to be properly. They would have to be compatible with each other, and only then everything works properly. You know, meaning from the client's point of view, it doesn't matter which you plug in, as long as they behave in compatible ways, in the sense that, for example, in the sorting example, for any two items that need to be compared, they're able to decide in which order those items should appear. Although the answer might not be the same for every pair of items. Does that make sense? So there's another example in the Uncle Bob pattern where he looks at rectangle versus square. So maybe we can look at that one next time to expand a little bit. So the open-close principle is, together with the Liskov substitution principle, is a key piece of object-oriented design. So open-closed is important in terms of being able to extend behaviors and let's see. So that's another consideration. Let's come back to that. So Liskov discusses the idea of being able to substitute things properly in terms of in behavioral or semantic terms that go beyond just the syntactic or type-based compatibility. No, okay, now I'm sorry. I got to correct something I was just saying. So there's a square versus rectangle example of Liskov, okay? And there's an open-close example of calculating the area of a shape, and the open-close example relates to, for example, the trade-off we observed with composite without visitor versus composite with visitor. And composite without visitor is open to adding more variants, for example, more kinds of fruits, versus composite with visitor, which is open to adding more behaviors easily. Okay, so that's another example of where you can see that trade-off. Okay, so yeah, I'm not quite sure what this J2ME preprocess is, but so J2ME is, that's not that widely used anymore, but it's a Java 2 micro edition for embedded devices, but it's not widely used. I mean, most Java on embedded devices nowadays is probably Android, and that uses a different architecture, so this is less of an issue now. Let's see. So here's a Liskov example, and here's the one with the rectangle and square. Okay. So if you assume that square is substitutable for rectangle, And if it lets you set a different width from the height, then you have basically a problem. So, how would Square violate this? So imagine you pass in, because you are, from a type point of view, allowed to substitute a square instance for a rectangle. So you might enter this method with R being a square. And then the question is, what is the meaning of setting the width versus setting the height? So the question is, if you set the width, will it also set the height to be equal to the width? So, or will it allow me somehow to turn a square into a rectangle by setting a different height from the width? My point of view is, well, if you had immutable objects, part of this problem would go away anyway. So that makes things easier. But let's say if they're mutable, let's say if your rectangle or your square can change their dimensions after they were created, how does the square handle this? So is this a square of size 4 after the set height, or is it no longer a proper square? Well, you'd say it better be a proper square still, because that would be even worse if the square allowed you to turn it into a non-square and still pretends that it is a square. Anyway, so let's assume here R is a square of size 4, but then its area wouldn't be 20 anymore. So here we have a case where square isn't a drop-in pluggable substitute for rectangle. So you have a violation of, even though syntactically you say, well, square is a subtype of rectangle. So this is a relationship is syntactic subtyping, meaning the compiler will say, okay, because square extends rectangle or whatever mechanism you're using, it's syntactically a subtype, but then the behavior violates the idea that you can always substitute a square for a rectangle, because in this method, things go wrong when you try to substitute the square. But again, it's tied to mutability. The mutability means there's a conflict between something being, basically something that you're modifying, so, or versus something you're not modifying. So it's related to when you have a container of something, whether you can assign to the elements or not. So again, when you make the shapes immutable here, this problem goes away. Yes.
I know this isn't the point of it, but have you seen programming where they've got a rectangle and then a square, and how do they solve the problem?
That's a good question. I mean, you really. So as I mentioned, so one way to solve it is just to say they're not modifiable. Then you wouldn't be able to do the set width or set height, and the area computation for the square would work fine. So in general, I think the question is, to what extent do you need mutability, and how do you deal with it? Well, you might somehow disallow certain modifications to the object, or you might simply say, let's see, you might have to maybe do a special case, but then it would open other cans of worms. So it's a complicated issue to deal with. So it really suggests that if you want to have a modifiable square, that is not a subtype of a modifiable rectangle in the Liskov sense, in the semantic sense. So these are tricky design decisions. So, and this is related to design by contract. The preconditions and the postconditions. So, for example, if you had a proper contract for the square, the contract would be, one of the terms of the contract would be that the width and the height are always the same. And if that's enforced, then from the point of view of the square, everything's fine. But from the point of view of the rectangle contract, that's no longer fine. Okay. Let's see. So let's continue this discussion later, or meaning next time, and let's spend a little bit of time on any remaining questions of project 4. But let me also point out, just so you can take a look. So basically, we got a little further than this part. So we got partway into what I had here for next week. But we'll have to do some of the concurrency overview. We'll have to wrap some of that up next week. So that's fine. I just wanted to show you very briefly. There is an example here of some simple situations involving threads. So if we clone this, I just wanted to spend a few minutes just to kind of get you started on this. Let's see. Okay, let's see. Okay, so let's follow the README. So let's say Gradle tasks. All right, this should tell me what tasks are defined in the Gradle build file. And these are the ones of interest. So we can run, for example, the simple threads example. So run Gradle run simple. Okay, so this runs a thread, and then at some point it interrupts the thread. So that we'll look at next time. The one I wanted to show you this time was the one that ties directly into some of the things we looked at last time, which is when you access a shared data structure from multiple threads, that things can go wrong. Okay, so just very briefly here, simple threads. So things can go wrong. Whoop, what's going on here? Even, what's going on with the network? Okay, no problem. Oh, here it is. Okay. Things can go wrong even when you have a very simple data structure. So here's a really simple data structure called shared, and it has just one value. So this could be like a click counter value, you know, that kind of thing. And it has an increment method and a get method and a reset method. So now the increment method is written in such a way that the increment is done in multiple steps, you know, deliberately, so that we can observe a potential problem in our experiments. So to increment this value, we first read the value into a local variable, then we have this little thing here that actually gets skipped. So this gets skipped because we say if false. So the then branch never gets executed. Then there's a thread yield method, which means basically if there's another thread or several other threads, the scheduler can choose between this one and others. Okay, as opposed to without the yield, this one would be allowed to continue, and we wouldn't see this issue arising that we're interested in studying. So then we'll say, okay, let's store local +1 back into the shared variable value. So in other words, 3 steps. One is read the current value into a local variable, allow other activities to run, if there are any, and then store one more than the original value back in value. So this does the increment, right? Everybody with me? It's just a complicated way to say increment value by 1. Okay. So if there are 2 activities that both want to increment value by 1, and they run either one just slightly before the other or kind of at the same time, what result do you hope for? So let's say let's look at the actual main method. So access shared just runs the inc method. And a thread is, as I mentioned, kind of an independent activity that runs in the background. So from the point of view of this main method, there would be one thread, T1, that tries to invoke the inc method, and another one, T2, that will try to run the inc method. But here, I'm just setting them up. They're not running yet. They will run as soon as I start them, okay? And then I can wait for both of them to finish. That's what the join does. But what the start does is it means the thread gets started and then you come right back while the thread is actually making progress and ultimately invoking this run method, okay? But the start method comes right back. It just spawns off the thread in the background. So in particular, when I say T1.start, it doesn't wait for T1 to finish. It just starts off T1 and comes right back. Then T2 gets started off, and then that start method comes right back. So right here, both T1 and T2 are working and running, doing something. That's the main thing to understand. Okay? So you might not have seen explicit threading. That's why I'm just getting you started here, and we'll discuss these kinds of things in some more detail. But what I want to show you is that things can go wrong. So what do you expect to be printed here? That is really the second last question I'm going to ask right now, and then we'll wrap up soon. What do you expect to be printed here? Any guesses? Or better than a guess. Who can say with confidence what should be printed here? If the program were correct, meaning that if inc correctly incremented that integer inside this shared object. Each thread increments it once. The result should be, how many times should it be incremented? Yeah, exactly. There's nothing more to it. You're probably thinking, oh, it's so complicated. But no, it's really simple. I mean, thread 1 is supposed to increment it once, and thread 2 is supposed to increment it once. So the 2 threads run, either one before the other or kind of at the same time, or taking kind of turns with their steps. That's the tricky piece. But ultimately, if each thread correctly increments the variable that was initially 0, what should be printed here? 2, exactly. Could anything else get printed? Maybe, right? And that's what we're going to look at, but I will I will show you that the answer is yes, and we'll analyze it next time, you know. But so let's do a Gradle run race, okay. So that runs this thing here. And, well, it looks like mostly twos, you know, but actually let's do a little grep and look at whether there are any ones. Not many, you know, so far none. But there are quite a few ones. Not that many, you know, not as many as twos. But so you see that something goes wrong when a 1 gets printed, so it loses one of the 2 increments that it's supposed to do. Does everybody see that? So in other words, in summary, even in a very simple situation, when 2 threads are given uncontrolled concurrent access to a shared data structure, even this really simple shared data structure that just wraps around a single instance variable, things can go wrong, and it has to do with the fact that maybe the threads, some of the steps of the threads overlap, and one of the increments gets lost. So we'll analyze that in detail next time. But imagine now if this were a more complex data structure, such as your user interface, and your button presses, you know, the listeners that process the button presses, and the internal timers were overlapping, or that code were overlapping, like the increment code here. It could mess up the state of the graphical user interface, and we would have a problem. And that's why most graphical user interface frameworks say all access to the graphical user interface as a data structure has to be sequential, meaning single-threaded. So anybody who wants to interact with the graphical user interface has to get in line. See, there's a queue for all events that have to do with or manipulate or access the user interface, and anybody who wants to do that has to get on that queue or get in line, and there's a single thread that processes these requests on that queue. And that's a fairly easy way to keep things safe, and at the same time make it easy for the programmer to understand what's going on. Because otherwise, you know, you would have a huge mess. But of course, with a single-threaded model, there are restrictions that we understand that we'll look at also next time in a little more detail. Any remaining questions about Project 4? You know, given basically the stopwatch skeleton, all the pieces are there, pretty much, that you should kind of mostly modify and rearrange, you know, as opposed to starting something from scratch. Most of you should have at least some partial functionality at this point. So any questions or concerns about Project 4 and the submission date of next Monday? Is everybody comfortable with the submission date and with your progress on this project? So, you know, now is the time to express any concerns. So, okay, I mean, if I don't hear from you, I assume everything's fine.
Can we have it pushed back till Wednesday?
Till Wednesday. Yeah, I mean, that can be discussed. Are there others who think this would be beneficial? Yeah. Yeah, okay, so, I mean, that's fine. You know, I don't like the due date to be on the class day necessarily, and you probably knew that, right, when you requested it.
Do we have a test next week or not?
And we have a test also, so it interferes with it. Well, okay, so let's do this. Right, so my hope was that we'd wrap it up early next week so that there would be some opportunity to prepare for the test as well. But I mean, what we can do with the understanding that this is going to be a firm deadline, we can push it back to next Friday, and then you can, without losing any time, you should transition to your work on the next project after that. Okay, so if we can all agree on this, that would be fine. All right, so does that help? Okay, great. Any other questions, concerns? Oh, of course. I mean, you can use any code from the examples. Absolutely. If there's anything for click counter you find useful, use that. But the reason I've been suggesting stopwatch is because of the internal timer event, where for stopwatch, you have the structure right there in that project. But sure, if there are other pieces that are useful from click counter, use those as well. All right. All right. That ends the screencast.